Welcome back to the CC scripting course. This is episode 2 and we're just going to get straight into it. So basically for this episode 2, I want to go over a few things like functional coding, bindable events, arguments, input outputs, etc. So getting a bit more deep into what actually coding is like instead of just going on the surface. So for this example, I've set up a folder in my replicated storage by searching folder. I've then called the bindables. I've added my bindable event and my remote event. We'll talk about these later. I've added my main part in the workspace I'm going to be transferring. And then I've made my server script and I've made my folder in my server storage, which I'm going to rename my part folder like this. And then I'm going to get my part inside of it and we're going to rename this main part. And then inside of my starter player scripts, I've got my client script. So first of all, we're going to talk about functional coding. So the most viable thing you're going to need when scripting Roblox is variables. So the way you declare variables by typing local, give it a name. So it could be like X, and then equals, give it a value. I could say 10. So right now the computer knows that X is equal to 10. If I go ahead and say print X and I run the game up here from script and then run, you can see it's going to print out 10 because we set the value of X to be 10. So what you would usually see is like by getting a value, for example. So in the server script, we're going to first of all need to get replicated storage. So we're going to type local replicated storage. And then we're going to set this to a value. We can't just say replicated storage like this, because while this will go ahead and print out replicated storage like we want it, it's not the actual function we want it to be. It's not giving the actual functionality we want it to be, because we want to look for something inside of replicated storage. And right now it thinks replicated storage is just a string with nothing inside of it. So to actually tell it that it's this service in Explorer, you'd have to do game get service, because replicated storage, like every other storage here things, is a service. And then inside of here, you want to type replicated storage. Now it knows that replicated storage is this service within the game called replicated storage. Same thing for the server storage. And the good thing to know here is that this has to be a normal script, because the way Roblox Studio works, the way most other coding languages work, is that you have your stuff on the server. So basically the script here called server, the white one, is my server script. I'll put it inside my server script service just so I can have it be on the server. And then I have my client script. But from the client, we cannot access the server storage because, as it is in the name of it, you're storing something on the server. If you're storing something on the server, you shouldn't be able to take it from the client, and you won't be able to either. So there's a few things like this. Like for example, on the client, you can do local player equals to game get service players dot local player. So essentially this just gives you the player. This would give me, so then this would be able, you would be able to reference anything within that, the actual player of the game, compared to on the server. If I tried to do that same thing on the server, if I did local player game get service players local player, as you can see, nothing pops up, and this won't work because we can't get the client code to be running on the server. Vice versa, you can't get the server code to be running on the client. That should be pretty easy to understand. But there's a few things like this which you need to know when you start coding on Roblox Studio. Same thing goes inside of the starter player, starter pack, starter GUI, etc. These are what you start with, funny enough. So when you run up the game, everything that's inside of these three services right here will be copied inside the player. So the starter GUI, if we try to and not run the game, but if we try to and play the game, the starter GUI will be copied into the player GUI. So a typical mistake is doing changes to a UI in the starter GUI, because that's just a template. That's just what you want the game that you want the player to have. But essentially, when we play the game, anything inside the starter GUI is being cloned into this player GUI. So if you want changes to the actual UI of the player, you would have to change it from player GUI. Starter gear is whatever is inside starter pack. Boom, gets cloned up to starter gear. So same thing as before. And then starter player scripts here is whatever script you have inside starter player scripts, of course. So I have all my Roblox codes here, Roblox script loader, blah, blah, blah. These are default codes to make the player work. We see we have a module with a bunch of different stuff here. And then I have my own client code right here. And same thing goes for starter character scripts inside of players. This is my actual player. This is what controls like all my variables, like what I see on the screen, blah, blah, blah. And inside of workspace, we have the same name as before, but this is my character. This is my actual character. You can see I have all the elements of my character. Most important one is humanoid root part and humanoid. So basically my humanoid is like my person. This is where I could control my walk speed, my jump height, my health, you know, everything that you would see inside the actual game is controlled here. And then all the scripts, all the values, etc. is being controlled inside of the actual player. So there's a good understanding for this. So even though they have the same name, you need to know that within the player's service is the actual player, and within the workspace storage, the name that matches up is the character to that player. Next up, we're going to talk about functions, because basically in Roblox Studio and like most other coding languages, function is what build the code. There's not a single game on Roblox Studio that does not have a function. Boom, flat out. So if you don't know what a function is, well, then you're not going to be able to code your own game. So listen carefully. Basically, inside Roblox Studio, when you're coding, you have something called scopes. Scopes is what the computer can see when it's reading. So all of these, or these two variables right here, are computer scopes. So the computer can see these things. So if I try to, we did not want a decal in there. If I try to do print replicate storage, as you can see, it knows what replicate storage is. Same thing for server storage. You can see it knows what it is as right here. However, if I have a scope, which is basically just a new layer to my script that the computer cannot read, well, that is where I then have code that can only be read in sections, and that is ups and downs, of course. But this is very vital to know. So the way you would declare a function in Roblox Studio is by doing local function, and you can do this both on the client and on the server. You can see if I on the server do local function, you can see it works like that. So you would do local function, and then you can press enter, and you see it's going to add these two parameters right here, but it's giving us an error. You can see the red line right there. It's an error. And every time you have a red line, you know there's something wrong with your script. So if you're running a script that has a red line, then of course it's not going to work because there's an error with it. But usually you can read in the output what the error is. So in our case, it's because we have made the function, but we haven't actually given the function a name. So much like you would give the variable a name, we haven't given the function a name. So I'm gonna call my function just to show you guys, I'm gonna call it number sum. So you've probably seen this before where you're getting the sum of two numbers. So what you would do is inside these parentheses is what's called arguments. So basically, the best way to explain this is whatever you put inside here, you can use inside the function scope. And we talked about scopes before, because basically, as you can see, this arrow right here is showing me another scope. The more arrows I have, the more narrow it gets into. But since you can see it's ending right here, we have like this arrow here, up and down. Within these two lines, line 6 and line 4, we have a new scope that the computer cannot see. So if I was going to go ahead and type local test equals to 5, and then down here outside of the scope, because we're outside of this little scope thing we have made here, if I was going to print test, as you can see, it's giving me an error because it cannot read test. It doesn't know what test is. So basically that is what a scope is, but you don't need to understand that perfectly for now. So for a number sum to work, inside of the arguments, we have to tell it that we need a number 1 and a number 2 because we have two numbers we want to add. So you can type number 1 and a number 2. And the cool thing about arguments is that as long as we just provide these two arguments, you see number 1 and number 2, when we run the function, we can call it anything. So number 1 and number 2 works for now, but we can change the name later. So then inside of here, we could say local sum equals to number 1 plus number 2. So basically just in math, right, where you get the sum, which is equal to the end result of the equation here, the plus equation. So now that we have the sum of the two numbers, we can do return. sum. So basically what is going on here is we're telling the function that we need a number 1 and a number 2. We're then getting a sum by adding number 1 on top of number 2, of course, and then we're returning a sum. So basically what return does is that every time we run this number sum function, we can take the value from the function. So basically if we say local sum equals to number sum, as you can see, since it's yellow here, you could also see when I was typing it, I'll do it again. You can see there's this red thing here. This means it's a function. And it's actually telling us here that it needs a number 1 or an A because it's an unknown, or a number 2, a B again, because it's unknown. So in our case, we know that we want 2 numbers add up, so we can type 5, 10. And then basically imagine that 5 and 10 is replaced up here. So number 1 is 5, number 2 is 10, as you can see. And then the sum is basically 5 plus 10, 15. And then we're telling it to return our sum. So whenever the computer has done the code, then I want to know what the sum is, so I can use it down here. Then down here, we're basically saying that the sum should be equal to whatever this is. So since it doesn't know what this sum is, it will know what this sum is. But just to show you guys, we could do number sum, just like this. Well, actually we'll do 2 m's because the function already has a number sum. And then if we go ahead and do print sum, again, since there's no scope, it doesn't know what sum is. We can go ahead and run this, but we will get an error, or it's just gonna say nil. Nil is the same thing as no or nothing, or just absolute nothing, so same thing as an error basically. But if we go ahead and say number sum with 2 m's, because that's what we called it, you can see it says 15. And this is because it just returned whatever the sum was. So it basically gave me 15. I ran the function, it gave me sum back, and then I told the computer what I wanted this variable to be equal to. And this variable is then basically equal to 15 here. The good thing is we don't have to call this number 1 or number 2. We can call this apple and banana. But then you'd of course also have to change it down here, since then the computer doesn't know what it is. So as you can see, it's not a number anymore, it's just apple and banana. And then we can just remain the 5 and 10. Actually, we'll change it to 10 and 10, and we will see it's going to print out 20. Because even though the arguments are called something else, it's the same principle that you're adding 2 things on top of each other. Since apple and banana are actually unknowns, but they do have a value, because of down here we gave them a value, then we know what it is. But if you want the computer to know that I want to put in a number here, you can do something called type checking, which says do 2 colons, space 2 colons, and then do number. So then basically we're saying apple should be a number, and banana, same thing, should be a number. So then down here, when I'm trying to get my stuff in, as you can see, it says apple should be a number. Okay, so basically I'll then give it a number. If I give it like a string and then 4, if we're trying to run this, you can see it has an error because it's trying to add a string onto a number, which it can't. So it'd have to be 2 numbers for it to work, and we're essentially telling whoever's doing this code that do a number, please. So then we could do 9 plus 4 in this case, and that would run us up to 13. So you guys get the point with this. This is what arguments are, and in some cases you're gonna have very, very long arguments. I'll show you guys an example. So this is from my own code. As you can see, I basically just have a bunch of tables here, which is just a way to store a bunch of stuff. And then inside of this function I've made here, I call it move vehicle, and then I've given it reps, model, direction, and start position. And then I'm using within this function here, it's a bit more complex than what we did, but then I'm basically using all these arguments to make my function work. So as long as I provide these arguments, which I do down here, as you can see, I say Tesla spawn, which is the same way as just calling the function, give it the function name, and then I'm giving it these 4 arguments that I told it to up here. And as long as I just provide the actual arguments and I have the right code inside my little function, well, then it's going to work. I could rename these whatever the hell I wanted, but it is going to work. That's just the takeoff you guys need to do. So even though our example right here, or not this one, but the one we made is a much more simpler, it's the same logic that goes into making larger system, because this is just a part of a larger system. So basically Studio is built up of a bunch of different components. You're gonna have a bunch of different scripts, as you can see in my thingy right here, a bunch of different scripts. And in each script, it's basically built up of what you learn in the beginning. So this is what I learned in the beginning, and these are the same methods that I'm still using today, and it's working perfectly fine. So back to our example right here, what I want to do from now on is whenever I get the sum, I want the sum to be transferred from the server to the client script so that I can see what my sum is on the client. Because right now, if I go on the client, I say print number sum right here. As you can see, it's going to give us 13, but then right here, it's not going to give us anything. And this is because it doesn't know what number sum is at all. So basically, the way we fix this, even though that is literally what we have right here, is we need something called remote events to bind the server and the client together. So I'm gonna animate this example right here. So basically the pink thingy is the server, the blue thingy is the client. So basically we want something from the server. So in our case, we have the number sum. We want that to be transferred to the client. And in most cases, you want something specific to be transferred to the client to then run server code into client code. Maybe you'd want to change something on the player, which you won't be able to do on the server, so you'd have to do it on the client. So essentially what our remote event is when we do the code correctly, it's like a rocket ship. So imagine this is the rocket ship right here, very beautiful. It's then going to take off here when we told it to. We're gonna fire it off, quite literally. And then it's going to land on the client code. And then with it, it's going to bring any data that we want. So data sounds very fancy, but essentially if we told it to bring a specific value from the server, it would then take this value with it inside its storage and then bring it over here. So then we can access that on the code. Vice versa, you can do the same thing on the client. If you have client code and you want to modify something, yeah, you can only do on the server. Then you just take off with the rocket from the client over here to the server. And then any value you have with it, any data you have with it will come to the server as well. This is how remote events work. And remote events is probably what you're going to use the most. And then you also have bindable events. And basically bindable events would be server-server or client-client. So it's from one server client or one server script, sorry, to speak to another server script. Vice versa, one client script to speak to another client script. And the difference you can see of these two is that this is called the bindable without this little white thingy here. This is the bindable event. You can also press on it and see it's called bindable event. And then this right here is called remote event. I've just renamed them bindable and remote. So yeah, I'm gonna show you guys this real quick. So essentially what we want here is we want to first of all tell the computer what our or where our remote event is. So within replicated storage, we're gonna say local remote equals to replicated storage. Actually, we're gonna say local bindable folder equals to replicated storage wait for child bindable. So here what we're doing is we're going inside the replicated storage. We're waiting for the specific thing that is bindable. So if it finds this bindables folder within here, it knows what it is. And then within this bindables folder, we're going to say local remote equals to bindable folder. Same thing again. And then we're just saying remote here. And I got to remove this down here. So now it knows what our remote is. Then when we have the number sum right here, we can say if number sum then. So if we have a valid number sum, it's not equal to nil. Then we can go ahead and we can say remote fire client. And basically when you're firing the client here, you need to pass the player first of all. And then you would, you pass the player and then you pass any argument. So in our case right now, we don't have the player. But if we had the player, then we could just be able to say player and then comma number sum right here. So then this would work. You could pick this up on the server by doing the same thing. If we just go ahead and copy all this in right here. We copy this and we don't really need the server source. We keep it for now though. And then we say remote on client event, connect function. And then you could do player comma data, right? Because we first of all give it the player right here. which we don't have in our case, so I can't go ahead and do this. You would need to add logic to get the player, which is a longer process on the server, and then you would do number sum. So basically, a way we could quickly do this is we could say local player is equal to nothing. So basically we haven't given a value. We could say for player in pairs. Alright, so we go ahead and done a quick fix. This will only work because it's just a showcase. I do not want you guys to add this logic to a game because it will simply not work. Essentially, we're going to look for all the players in the game using a loop. And then we're going to set this player value to me. So we're going to do print player, and then we're going to do test.wait5. So essentially, again, this code, do not run this code on your own. It will not work. This is just purely to show you guys what remote events are. So as you can see, it finds me a script casual, and now we can fire this this thing right here. We can fire this number sum because we have given it player and we've given it a number value. So then we could, inside here, we can print player comma data. So I'll go ahead and remove this, and what we will see is that after 5 seconds, because we have the 5-second delay, oopsies. As you can see, it says 13, nil, and this is because I actually did it wrong right here. We're just going to and say data right here, because you get the player by default. That is my mistake, I forgot that. So then you would do print data. So then what we'll see right here, or what we should see at least, is 13. So it printed out 13, which was our value from before, 9 plus 4. So essentially we fired the client, we gave it the player that it should fire to, we gave it a number sum. You can also, if you don't have a player, you could do fire all clients, but then it'll be visible to every single client, of course. And then inside of here, we basically pick it up when it's being fired. We're waiting for it to be fired, and when it's then fired, we pick it up here. This is the event, and then we're connecting this event to a function. And then we're not giving this function name. We just, because we don't need to when it's connected like this with the event, we just pass in the data that we send from the server. So essentially the number sum, and then it's printing the number sum. So this is basically about more of that functionality coding. Quickly, we'll go over some loops. So one way to loop is for I equals 1, 10 do. This is a for loop because there's a for. So I is basically the interpreter, whatever you want to call it. So for I equals 1, 10 do, we'll do print hi. And then we'll go ahead and get rid of all this other code right here. Just so we only have this. So if we play the game, you see it's going to print hi 10 times. And if you wanted it to wait a second before doing it, we could do test.wait 1 like this, because then we're telling it for every time this runs, it's going to run. Every time it runs, it's going to go 1 to 10, right? So from 1, 10. So every time it does this, inside this scope, it's going to run 10 times, and it's going to run 1 time at a time, of course. Then it's going to print hi, and then it's going to wait a second, and then the error is going back up, and then it's going to do this. I'm not going to explain loops in detail because there are much better videos on YouTube I want you to watch if you're having issues with it. But essentially, as you can see, it's printing hi with a 1 second interval. Another very common loop is you could also do while something do. So this is a while loop. Usually you would see a while true do. You could then print hi. This might lag out our game because it is always true. As you can see, my game is lagging right here, it's not loading, and this is because we're essentially saying that while it's running, which it always is, it's as you can see, it printed 1,900 times. Again, not ideal, and it seems like our game might have crashed here. So yeah, our game crashed, not ideal. I've gone ahead and opened up a new base plate right here. So the way to fix this, you could do while test.wait 1 do, and then you could do print hi, because essentially it press on this. There we go. If you run this, you can see that every time there's a second, it's going to print hi. You can also lower this There we go. You can also lower this weight to see that it prints much faster now, but even though as long as there's just a small weight, the computer, the server can't handle it. So that is all good. You can see it's printing high very, very fast. These are the milliseconds, these are the seconds, minutes, hours, of course. So essentially this is working. It's gonna keep on doing this because we're telling it to. Another loop you could do is a more advanced for loop. So we could, for example, check every single player in the game. So first of all, we get the players service. So from before players get service players, you could do for underscore, or we could do for I comma v in pairs players get children do. So basically it's saying for I comma v. So I remember what it stands for. I know V is for value, but for I is essentially the number in the order that it is from, and V is the actual value of it. So I believe it is index comma value, if I'm not wrong. So index is the number of where it is, value is the actual value of the thingy. So essentially here we're telling it that for every single index and value, so for every single instance, in pairs, so we're pairing these two up in players, so that is the folder that's controlling how many players we have. We're getting all these children do. So we're basically checking every single player in the game, and then we're pairing it up. So if we go on ahead and do print index comma value, and then we add a small wait to make sure the character loads in before this code runs. As you can see, it's going to print 1 script casual, and this is because in Lua and most other thingies, every time you loop for something, a table, it starts at 0. In Lua, it starts at 1. So, and as you can see, since I'm 1, I'm the only player here, and then so 1 would be my index. Script casual will be my value. So you can also do this with anything else. You could do it with instances in Workspace. Same thing as before. You can also do it with tables. And quickly, just to go over, tables is a way to hold data. So you could do local my table and then add these two parentheses. And this is basically calling this a table. Now it's a table. And tables at on the top sound very weird and very hard to understand, but it's really not. Basically, we give the table a value. So in our case, I'm going to, first of all, give it a string. I'm going to say, hi, I'm casual code, and then I'm going to give it the random value of whatever that number is, and then we're going to give it a Boolean value. Boolean is basically false or true. Very, very important you know what all these are, or at least you do research after this video. You get to know what all these are, because I'm not going over these small details as much. So basically inside this table right now, we have the hi, I'm casual code, we have a string, a number, and a Boolean. Just to show you that it can hold like any type of data you really wanted to. So then if we did for index comma value in pairs, and then we just checked our my table. So for each instance and value inside of my table, we'd go and print this. So basically what we would see in output is that the first value is the string. So the string is the value of 1, or the index of 1, and the value is I'm casual code. The second one is the number, the third one is the Boolean. So it works like a charm. And you can do this. For loops are being used for everything. You need to know what for loops are. While loops are also true, but as long as you know what for loops are, you know what, okay, wait, well, actually we'll do a list real quick. If you know what, to take away from this video, for the next video, if you want to keep along in this series, generally you want to keep along in Roblox Studio, you need to understand what variables are, functions, scopes, for loops. Okay, so basically this is essentially for this video, but moving forward, also if you want to keep up with coding Roblox Studio, you need to know what these things from this video are actually inside of functions. We'll go ahead and add arguments. So variables, what we talked about first, it's a thing you give a value to. So players up here would be a variable. Functions is, of course, the functions we did earlier. And then we added the arguments. We added these, we talked about the scopes of the function, and we talked about for loop, while loops, and RAs and BEs are the remote events and bindable events. So as long as you know what these are, if you're uncertain of any of these, then before the next episode, which is going to drop in plus minus a week from you hearing or seeing this video, then you are basically good to go. So do your research, understand what all these are, and then you're good for the next video. I promise you, if you keep along with this series, when it's done, it's about 10 episodes planned, then you are going to be able to hop on your own, maybe after a week's practice or so, and then start coding for yourself and making that fat bank. So of course, if that is what you want. So yeah, you can take notes of all this, you can rewind the video, do whatever works for you, but just for the next video, know what all of these different thingies here are. Alright, that is all for episode 2 of the CC scripting course. As I said before, episode 3 is probably going to be next week, plus minus. I'll see what I can fit in my schedule. And next week is going to be, if you thought this video was intense, next video is going to be even more digging in. From now on, we'll only go about bigger stuff, and I'll be explaining each thing's less. So I've tried to explain all this as well as I can, and it won't be, from the future videos, things won't be explained as much in detail as today, because we have a bunch of stuff to go over and we only have a few videos to do it on. So yeah, that is basically all for now. Catch you guys later in the next video. Bye bye.